Morning, folks. Today I've got an Adcom GFA-555 amplifier up on the bench. These are powerful amplifiers rated at 200 watts per channel, and they're well built. A lot of people, however, are leery of them because they have no internal speaker protection circuitry. So the project today is to install one of these boards you can find on the auction site. I like this particular style of board because this has an AC power supply built into it. Some of the ones you buy are DC, and they'll require you either tapping off the power supply in the unit you're installing it in or installing another power supply. This does not. This will run anywhere from 85 to 265 volts AC. So you can tap it off the AC circuit no matter what part of the world you live in. And these are quite inexpensive. I think I paid $15 for these. Bought several of them several years ago, and just getting around to doing this now. So I'll show you the process I use to install this. It's fairly simple and straightforward. Fortunately, there's plenty of room inside the amplifier for the installation. So I'm going to outline all the steps we have to do to make this happen. So the first thing we want to do before we do any work to this amplifier is make sure everything is properly functioning before we install it. It'd be unfortunate to install the board, then have a problem, and realize it had nothing to do with your installation. There's a problem with the amp. So I'm going to turn this guy on. You can see it jump because there is no delay. The output's just directly connected to the speaker terminals. The output modules are internally fused, which provides some protection, but most people feel better if they have an internal speaker protection circuit. So I'm going to turn the signal on, and the unit's auto ranging, and we are putting out about 150 watts a channel. Let's see, it's supposed to put out 200. It's starting to clip a little bit. We're here at 191. Distortions jumping up more on one channel than the other. Yeah, it's not quite squeaking out 200 watts. So we're going to take a look at that. Anyway, the amplifier does work, and that's the key point. So we'll install this, and then we'll take a look and find out why we're just barely squeaking out the output that is designed for. Could be the filters are getting tired. That'd be unfortunate because there's a lot of them in here. Before we do anything else, I want to give you a closer look at this protection module. It's got two relays, one for each channel. This is the AC power supply on the board. They come with the standoffs on the wrong side. Don't know why, but anyhow, we're going to have to put these standoffs off on the other side and screw them onto a board. What I generally do is I cut a piece of metal in an L shape with a small flange at the bottom, the lower part of the L, and then I just screw this to it. And what I'm going to use for this is the cover to a box which I no longer have, and we're going to just mount this to that like so, and probably cut a little of this off and bend it over until we have something we can drill a couple holes in and then screw to the bottom of the board, and the unit will be standing up inside like this. So that's the plan. I'll show you step by step how we do this. Okay, so I got the mounting bracket set up with the protection module, kind of screwed up the holes in the bottom, but this is not something you're going to see. And I have drilled two holes back here, and here, if you can see that, and that'll allow mounting of the module. Now the only other things we have to do is we have to connect the output of the amplifiers in, and then the output of the module to the speaker terminals, because it's just going to go in series with that. The other thing we have to do is we have to get AC power, so we're going to need a line and neutral feed here. And those are real hard to see, but down in here there is a terminal strip we're going to have to get to. And I may have to kind of push the, unscrew some of the screws and push the back in order to get to it. But what we need to make sure we do is whenever we're dealing with electricity that goes through either a switch, a breaker, or anything that can interrupt the flow of current, we have what's known as a line side and a load side. So we want to make sure we're on the load side of the switch, and that way when the switch is turned on, it'll power up the module. If we get on the line side, the module will be energized all the time, and that's definitely suboptimal. That's not what we want. So we need to make sure we are on the load side of the switch, and we have to connect the neutral directly to the neutral coming in from the cord. So I'm going to mount this at the very end. I'm going to run all the wires first, and then we'll screw the module in, because it's a little fiddly trying to get the nuts on here while I have the module in like this. So that's where it stands right now. Next thing I'm going to do is I'm going to try to take enough screws out to where the back will move, and we can get to the terminal strip down there. And also we need to get to the speaker terminal, so we may have to pull the preamp board off, or the driver board. Okay, so I've got this Adcom set up on its side now, and I've removed one of the transistor modules here with the associated heat sink, and also the back panel. I have the banana jacks and the input and the driver board. I wanted to expose our terminal strip so I can tap into the neutral here. We're going to tap into the power switch on the load side, but we need to hook into the neutral so we can power our protection module. And after looking at it, there's two terminals on the terminal strip that you can plug spade connectors onto, and we're going to pull off the one that feeds into the amplifier's transformer, so we can use a larger one and get two wires crimped into it to slide back on. Okay, so I've got both wires in the one terminal, and by the way, I incorrectly referred to this as a spade terminal. It is not. These are called male and female disconnects. Kinky, huh? The things you learn if you read the front of the box that they come in. In any event, while I'm not crazy about putting two wires in one terminal, I soldered it to make sure I have a good connection. While the old one was insulated here, it doesn't really matter. Everything else is insulated there, and it's going on the terminal strip where there's going to be zero motion, so I'm not worried about that. So now we have a neutral that we can run to our protection module. So I'm going to plug this back onto the terminal strip, loom the wire through roughly where it's going to go, and then we're going to work on getting a line terminal from the load side of the power switch to power up our module. Okay, so after fishing around and trying to get the terminal plug back onto the terminal strip, I wound up pulling one of these disconnects off the top so I could actually see what I was doing, and it went a lot quicker that way. So if you wind up taking this route, I recommend you do that. Then you can see where you're going. I took a pair of hemostats and grabbed the wires and pushed them on. I don't know if I mentioned, but I soldered the two wires into the terminal because crimping them was not working. One of them was going to pull out, and that was unacceptable. The module is not going to pull a lot of current, but the neutral to the transformer will. So I wanted to make sure we had a solid connection. Alright, so I need to tap to the load side of the switch, and that goes back to our terminal strip here, and it appears to be the second terminal. Now I'm going to have to move the camera so you can see down in here. If you can see right where that chopstick is, this is where I have to go. And I determined that by putting my meter in the continuity mode and checking over here. I got my meter connected to the line side of the plug, and when I put the other side of the meter here and actuate the switch, you can clearly hear that that is our load side of the switch. So the line side of the plug is connected to the load side when the switch is in the closed position. So we're going to tap into that one so we can get our 120 volt line side from the load side of the switch. I know this is getting a little confusing. It's really early and I'm easily confused, but the point is we need to be able to get that voltage into the module to power it up. and it has to be on the load side of the switch so it is not energized all the time, which would defeat the entire purpose. Okay, so I've got the other lead that's going to power up our module. I have a wire tapped off of here. This goes to the transformer, and I'm going to put it back onto the terminal strip. I put some heat shrink on this one because the insulation pulled back a little bit when I was soldering the female disconnect onto here. So I just did that for general principles. There's really nothing you can touch around there, but it's always better to be safe than sorry when dealing with AC voltage. Depending on what part of the world you're in, this could be anywhere from 100 volts to 240. So a little heat shrink and a minute of my time was certainly worth it. Okay, so I've got the AC taps put in place. I've loomed the wires through roughly where we're going to go. We'll cut them to size when we're ready to mount the module. I'm going to test it first, but before I do anything, when I removed this output module, this bias tracking diode pulled out of the clip, or I pulled it out of the clip here, and I'm not sure if you can see where that is, so I'm going to move the camera a little bit so you can see right down in here there's a clip. And I put some fresh heat sink compound on here, and then we're going to slide it back in before we test it. I may put a couple of screws in the bottom here, but I think it's pretty stable, so we should be able to AC test this thing. And we just want to see if we can get the module to pull in. So I'm going to get that set up, and we'll come right back. All right, so I have the module connected by clip leads to the switched hot or line side and the neutral. I have it connected to the dim bulb tester, but before I go any further, if you're doing this kind of work at home, you're doing so at your own risk. We're dealing with line side here, and as I mentioned, depending on what part of the world you're in, that could be anywhere from 100 volts to 240 volts. These are potentially lethal voltages, so you need to exercise caution. Now, I keep pieces of wood and cardboard around for isolating and insulating things like this when I'm working on them. And currently I have a clip lead here and here that are going to the module. So when I power this on, it should eventually click, indicating it's coming out of protection. Now, I haven't hooked up any of the speakers. That's going to be the second phase of this. We just want to get the module powered up and make sure it works. It's going to take a little longer than normal because the dim bulb is going to limit the current. And spoiler alert, I've already done this, and it takes a while for that bulb to dim because there is a lot of capacitance in this guy. And I'm using a 100-watt bulb. I could go up a little higher, but in the interest of safety, we're just going to leave this as is. So I'm going to turn this on, and I'll show you the dim bulb just so you have an idea how long this takes, and then we should hear it come out of protection. Okay, I have the switch off, so I turn the switch on. Bulb glows brightly, slowly dims. I don't know if you heard it, but it clicked out of protection. Okay, so our power works, our switch works. Looks like we've got that phase of it done. So the second phase is where we're going to break the connection on here from the bananas, or the 5-way binding post. I've been corrected about that. From the output terminals, we're going to remove the wires, connect them to our protection module here, and then we're going to take the wires out of the protection module and connect them back up to our binding post here on the back. And that's how we provide protection for the amp. Remember, protection circuits simply break the circuit between the output stages of the amplifier and the binding posts or banana jacks or whatever you want to call these terminals. Okay, so the easiest way to gain access to these terminals is to just take the driver board off. Now, both of our bias diodes pulled out. They pull out very easily, so you have to make sure these are back in before you complete the job and put the cover back on. So in order to get this board off, there are 2 screws that hold it here, and then 2 screws that hold the RCA connectors. Those feel a little loose. I'm going to check the soldering before I put back in. It's probably fine, but anyway, while I've got it loose, no reason not to test that. So what we're going to do is we're going to take the 2 wires off of each one of the positive terminals, and we're going to put it into the speaker in terminals right here. We have a left and right. It has a ground. We don't need to utilize the ground. If you notice in any internal protection circuits, they don't use that. Maybe this was made for other types of amplifiers, but we don't need to bother with that. This is not a floating design, so we can just connect these and leave the grounds, which go right to here to the bus bar, and we can prove that by going into our, let's see which leads I have connected to my meter. But if I connect to here and tap these guys, you can hear this just goes right to ground. Most amplifiers, unless they're a floating or balanced design, are going to be designed like that. So we're going to leave those alone, and we're going to pull these guys off, put them in the module, run wires from the module back to here. Now the small wires are our feedback, so it's very important they stay connected here. So these both have to go into the module. All right, you can't just leave this one here. So we're going to take these off, put them into the module, run a wire back from the modules to here. Then we mount the module, and everything should be completed. And we'll give it a test after that, and I'll show you how it works. Okay, we proved that our AC power to the relay works. When we switch the amplifier on, we hear the protection relay click after a few seconds. So that phase is done. The next thing we have to do is we have to disconnect the speaker outputs from the amplifier right here. This is left, this is right. And then what we have to do is we have to connect those to the module and run wires from the module back to our 5-way binding post, banana plugs, or speaker terminals. Very important. This is the output wire, but this thin wire is our negative feedback line, and it must stay connected to our output. So we're going to put both these wires together into the inside of the protection module, and then we'll run the single wire back to here. Now it's very important to tie these together, because if we left this here, we wouldn't be able to ever get this amplifier out of protection, because our negative feedback loop would be open, the DC voltages would be all out of whack, and our protection module would be prevented from closing. So very important that we tie these together and put them into the inside of the protection module, and then, as I stated, we'll run a wire back to here with a ring terminal that will tie down to this. Alright, so I got the terminal off of the speaker here, and we are going to cut the ring terminal off, and I solder some extension wires here and here on the negative feedback. So we're going to slide some heat shrink over these, and I'll loom them over here. My goal is to have all the wires in this general area, put them on the module, and the last step will be mounting the module to the bottom. It's just easier to work with this while everything is free and I can move it around, because once this becomes mounted, I don't know where that one is, but it's right around here underneath all this crap on my bench. Once we mount that, it's going to be a little easier, a little harder to get everything in. I'm not sure if I can get a screwdriver in here, so we'll do it so I can turn everything, get to everything, and the last step will be to mount it down in the amplifier. Okay, so I have both outputs, left and right, connected to the protection module here. Now this is the speaker in, and you'll notice I have 2 wires going in each one, so we have our negative feedback path, and I have verified that our negative feedback path is good using the audible continuity function on my meter. Very important that that's good. Now, in anticipation of finishing the job, we need to connect these to our speaker terminals, and I have already got these connected to a couple of ring terminals and snugged down very tight onto our speaker terminals. So now we have to loom these wires through or run them to here on the speaker out of this. Now the in and out shouldn't be critical because you're just closing a relay, but I'm just going to follow the convention in case somebody else has to come in here after me and work. Everything will be laid out as it should be. So once I get all those terminated, I'm going to throw a piece of cardboard in there, mount everything back up here. We're going to give it a quick test on the dim bulb, make sure it comes out of protection. And if it does, I'm going to feed a small amount of signal in, and we'll watch the scope to see when the signal comes through when the relay closes. Alright, so I have finished wiring everything. The last step is going to be to mount the protection module in the bottom of the amp. Not going to be a lot of fun because I have to hold the nuts while I put screws in the bottom, and I'm definitely doing that off camera because you don't want to hear it, trust me. So I've got it hooked to the dim bulb tester, and we're going to see if it comes out of protection. I put all the screws back into the driver board, and I noticed that our bridge stereo switch had got knocked into the bridge position. Usually that's not something I'd notice. I'd test it, have a problem, not know what was wrong. Just so happened I took a look at it. So we want to make sure we're in the stereo position when we go to test this. So we have our inputs here, our outputs connected to our binding posts on the back, and I have a piece of cardboard in here with the module just sitting against it. I mean, it shouldn't be a problem, but I didn't want it to touch any of the hot leads on the capacitors. So I'm going to turn the camera onto the dim bulb tester, and we'll turn it on. And speaking of problems, if you'll remember at the beginning of this video, I was not able to get full output out of this amp before clipping. My normal MO when testing an amplifier is after I get it off the dim bulb, I plug it in here, which goes through the variac. And the variac had been turned down a little bit, and therefore I wasn't getting 120 volts in. Therefore, I wasn't getting 200 watts per channel out. Once I noticed that and cranked it up, everything was fine. So that was the problem there. So I'm going to put this here, and we're going to listen for the click of the protection relay. Relay clicked. You'll notice that it took quite a bit of time to dim down. That's because of the sheer amount of capacitance in this amplifier. The more capacitance you have, the longer it's going to take to dim. The healthier the capacitors are, the longer it's going to take to dim. In some countries, they refer to the power supply filter capacitors as reservoir capacitors, and I kind of like that term because I find it's more descriptive as to what the function of them are. Okay, so I've got my distortion analyzer connected up to the amplifier, got the speakers going into the dummy loads which go into the input of the distortion analyzer, and I'm going to turn it on, and we shouldn't see anything on the scope until we hear the relay click. So I'm going to turn it on. It's on. Relay clicks. We have good signal. That jumping around is the auto ranging in the distortion analyzer. So the module is working correctly. The final step will be to take the module and mount it into the bottom of the amplifier. So after I get that set up, we'll give it one more test before we put the cover on. By the way, in order to save wear and tear on your relay contacts, it's always a good idea to turn the volume down, or in this case the signal off, because they can arc when they open up. So we want to prevent that from happening. So if you turn the signal off, it'll extend the life of your relay contacts. And that goes for any amplifier that has a protection relay. Okay, so I made my life more difficult than it should have been or needed to be, which is sadly a recurring theme. But what I mean is, I could have made this bracket at least 2 inches taller, which would have made getting the nuts on the bottom of this a whole lot easier. So what I wound up doing was, in order to give myself some space to work, I loosened up the power transformer, which is this toroid down here, and slid it off to the side so I could get to the nuts to tighten them up. I have screws in the bottom, nuts in the top. So now it's firmly mounted in here, and everything works. I'm going to put a very low level signal in, only because I don't like to have the contacts closed with a lot of signal or open with a lot of signal. Open is worse than closed, but always nice to err on the side of caution. So 20 millivolt input signal. We look at our scope, turn the power switch on here. Oh, I need to turn our signal. Power switch on. Relay clicks, we have signal. Okay, so now let's see if we can get full power out of this. All right. And let's see, that's okay. 138. 175. I'm going to go manual here. And we get 200 volts before the onset of clipping. So this guy's doing what it's supposed to do now. So I'm going to put the cover back on, and we're going to put a little music through here. Okay, so we've got this thing all buttoned up. I'm sorry for all the noise. The air conditioning for the house is running. Air conditioning for the garage is running. It's just hot down here. It's hot all over. I'm in South Florida. At least we don't have heat domes like they had in other parts of the country. But nevertheless, I have a CD playing, and I'm going to turn the amplifier on. I do have volume on the preamp up, so you will hear it as soon as it clicks out of protection. The other thing that's really nice about having protection relays is you don't get any turn on thump or turn off thump, because the relay opens up as soon as I kill the power. There's no noises at all. So anyway, that concludes this video. I hope you all enjoyed it, learned something, and as always, I like giving back to the community that's given me so much. Thanks a lot, folks.